Welcome to the Nautel NAV Kenta webinar. My name is John White. I'm the head of marketing and product strategy for Nautel. Today's topic is modern IP based GMDSS. This is a topic that is very personal to me. I've just spent the last week at sea, so safety at sea is something that matters a lot to me as well. I want to thank you for joining today. We have attendees from all points of the globe. In fact, we have a strong representation from integrators and even our competitors. So to me, that's a great endorsement for the efforts and solutions that Nautel and Kenta are bringing to our customers. Today, this webinar series, we're hoping it may be the first of several. It's all about education, and it's all about having content that's useful for you. So there'll be opportunities for feedback, and also we'll have opportunities for questions, and I'll touch on that in just a moment. Let's get into meeting our speakers and taking a look at the agenda. So today we have joining us Hermann Zensen. He's sales and marketing for Kenta with an engineering background. Welcome, Hermann. And also we have Marc Dumont, who's part of the R&D team here at Kenta. Welcome, Marc.
Hello.
And so today's agenda, thank you, Marc. Today's agenda, we'll do a quick introduction to Kenta and Nautel NAV, but try to quickly get into the key material. We'll just touch basically on the terrestrial GMDSS system, but get right into how leveraging standards gives us a better solution, and I mean the industry, a better solution for GMDSS. So the IP protocols, we'll look at those. ED 137B standard and SIP, and then we'll go into a live demonstration of the to show how these technologies can be put to work, and then we'll take some time for questions and answers. And let's hit the next slide and we'll explain how the question and answers work. So first of all, you're going to notice on your toolbar there's a orange button at the top that lets you toggle your control panel on and off. If it's hidden, you hit it, it'll pop back up. And you'll see lower down, when you expand that panel, an opportunity to post questions. And we'll try to get questions. We may take some of them within the proceedings of the information that we're providing through the day. We may get to some of them at the very end, and some we may have only time to get back to you at the very end of the discussion. So with that, I'm going to hand it over to Hermann and Marc. Thank you.
Yes. Good morning, Europe. Good afternoon, Asia, and yes, early good morning for America. Thank you very much for being with us. Yes, just the first short slide explaining you how Nautel and Kenta, how it is together. Well, Nautel, I think maybe most of you know, Nautel is well known for broadcast for AM and FM transmitters. But historically, they started with maritime business, because Nautel, it is the word nautical in it. Okay, so they started with maritime, and we still have, this is what the logo that you saw on the very first slide. We have the Nautel NAV brand that is still selling maritime equipment. And Nautel is based in Halifax, so the headquarters and the sales for Nautel NAV, they are in Halifax. And the production for a maritime is in the United States, in Maine, in Bangor. Okay, so this is for Nautel, and Marc and myself, we are based in Europe, in France. So yes, we work for Kenta Technologies. Kenta Technologies is 100% subsidiary from Nautel. So Kenta is a brand for Nautel for the maritime communication. So we have two places, same thing, two places here in France. We have Rennes on one hand, where Marc and myself are today, and we have Quimper, which is the place where we have where we produce the maritime equipment. Okay, we are just for your information, Kenta is a member of two organizations in the maritime business. We have CIRM, which is linked to IMO, which is the industrial consortium that is an advisor for IMO. And we have Ayala, which is more about AIS and BTS. We are a member of both. Okay. Yeah, just some short words. Yes, so Nautel in total 200 people, 54 years experience, outstanding financial stability. Kenta was founded in 1990 as a Furuno spin-off. with focus on maritime communication right from the beginning. Our GMDSS product line, we do this since 2013. The very first systems we had were in Mauritius. Just for you, compared to other companies, we do all our software, all our hardware is developed internally. So we have no third-party products for the GMDSS part. The key competences here are on IP technologies. So all our products are IP on radio communications in different frequencies, which is a medium wave, high wave, and also VHF. With typically, yes, our transceivers, transmitters, receivers, they are conceived as IP RF gateways, if you want. So it's really all about IP and also a technology we call software-defined radio that makes it now much easier to have different types of equipment. Okay, and we have a strong experience, field experience on the lower frequencies. You might know that Nautel, they have AM transmitters, and we are also in the lower frequencies here with, especially in the maritime communications, less than 30 megahertz. Okay, so we typically, the Coast Guards, they will ask us if they have a complicated site and they don't understand why there are interferences and like this. So our team, we have a good experience in finding out what's wrong. Okay, so this brings you then right to the topic. We are here on, yes, today we are on terrestrial GMDSS. I think most of you know this, no need to introduce it. So we have the 4 areas, A1, A2, A3, A4, defined as by IMO. Yes, we have the coast stations, which can be for NAVTEX, for VHF transceiver station. It can be MFHF transmitter or MFHF receiving, okay? And with this, we cover the 4 areas, okay? Which means A1 would be in VHF, A2 in MF, and A3 and A4 in HF. These are the communications we are talking about. We are talking about IP-based systems, so it means, yes, if we have satellite communications, it's possible we will not have the satellite systems, but we can have a connection, you know, IP interfaces to interconnect, which makes it way easier. And you can see here it's the MRCC. So all this, the MRCC and the coastal stations are linked together and all over IP. Yeah. So yeah, well, IP, this is something, well, it's all industry are leveraging IP standards today. So it's not just in the maritime industry. So we have this also in, for example, the broadcast, we see this typically, especially in digital broadcast, where all the communication from the studio to the transmitter will be on IP. So it's something which is anyway happening everywhere, okay? And why? Because yes, there are several reasons for this, because it makes it very easy for you to control, configure, and update remotely. You can have maintenance, remote maintenance. The monitoring is easier. You have less cables and stuff like this, so you only need IP connection, okay? And you can have audio and data, everything on one cable. We have one big advantage now, because contrast to 20 years ago, now we have IP networks with high bandwidth, so we can use more bandwidth, which gives us more possibilities. And in the case of maritime communication, yes, very often we have unmanned sites now, and this is the perfect technology for having unmanned sites and remote operation. So in the webinar here, we will discuss several standards. You can see we will have HTTP, FTP, RTP, SIP, and also ED137. These standards are open, yeah, and very, very common standards, okay? So it's really, yeah, in our products and in general, you can have maritime communication with very common standards, maybe with the exception from ED137, which is really a specific standard for voice communication in air and traffic, in air traffic and maritime communication. Okay, so let's start with the ISCR, sorry. Yeah, well, the standards we will discuss. Well, this is the model, the internet protocol layers we have. Well, if we take the TCP IP model, which is the mostly used one, we are not in the physical layer, we are not in the network layer, we are not in the internet layer, we are only in transport layer and application layer for the standards that we use for maritime communication. Okay, just that you know where we are. And we start with the most common protocol, which is HTTP. Well, HTTP, yes, this is we are on the application layer. Okay, it is well, it's used for distribution of hypermedia information system. This is the this is the standard that is used in the World Wide Web, and it means also today you're within the webinar, you're sure that you use also HTTP technology to access. It has several advantages. It's very popular, so very well documented, and we can easily analyze it with Wireshark. So we have good tools to analyze this. It's a client-server orientated architecture. Okay, so basically the client, which would typically somebody on a PC would ask with a web browser, a server, and then the server would respond. Okay, so we can do polling. It means we can also drag information from the server if needed. Mainly the data we change, we are in XML. Okay, we can have compression, and it's quite fast and with open session, so it has a keep alive support. Now this is, yes, where do we use it in GMDSS? We would use in GMDSS, we would use this protocol for monitoring and control, for the frequency setting and getting, and also for the alarms. Okay, so we have here a short dialogue that you can see, well, it looks to me this is probably somebody asking for hello HTML file, but we have Marc with us. He will explain you this one.
Yes. Absolutely. The left side is in fact the request made by the HTTP client, which is the client inside, in fact, for example, the GMDSS server, and asking to the transceiver how the status is. So it sends a request with the get with the appropriate file. So I want to know that what is the file status, for example, and in the response sent by the server, there is a header part which is say hello, I'm the server, this one, and finally the response with the appropriate file contents. And in our GMDSS server, in fact, we will ask for XML files, and inside XML files there will be some information like the current power settings, the current frequency settings of the transceiver, and of course we can also send specific requests to give orders to the transceiver to transmit or to change frequency or something like this. So there is always a request calling for a response, and that's it.
Okay, good. Thank you. So you can see that Marc is the one who develops the server. He knows this very well. Okay. The other protocol we use is FTP, which is, I think it's older. No? It's older.
Yeah, it's older.
Older than HTTP. It's yes, it basically, this is about file transfers from a server to a client. So we also have a Zensen client server model here. And yes, the typical thing is, yes, but most of you know this probably. Yes, you just have you have to authentication with a username and password. This is a very common protocol and easy to use protocol. Yes, which is used. Yes, which is used. Same thing. We have XML files. Mainly, we'll exchange mainly XML files out in our solution. It is not so fast. It's older, as we said. There's no compression. Okay. And in the case of GMDSS, we use this typically for transmitting NAV text and DSC messages, in the form of XML files. So we would try to pull the messages from the RX from the receivers to get this to the server, and to push from the server to the transmitters to send them. Okay. And here we have a short, yes, an example of the FTP protocol. So yes, so you can see what we have discussed before. We have here an identification with the user and password, and some other things, Marc.
Yes, in fact, here you have a simplified version, which is a FTP client line, command line. Someone is typing explicitly the commands. So it's not exactly the FTP protocol, but very, very likely. So yes, you see the first on the left screen, the user is sending in blue colors these commands. So it changes login, password, of course, has been hidden here. You can change the directory to a specific one, list the file with ls command, can list the file, so we can see the server answer there is file1.xml and file2.xml, and then the user decides to get the file1.xml and then receive it locally and can process it later. So it's still the client who decides what he wants to do, and the server just executes his orders.
Okay, so far so good for FTP. And then we come already to RTP, real-time protocol. I guess most of you have heard about this already. So here we're in the transport layer, okay? And this is a typical protocol, yes, used for voice over IP systems, okay? So it can use not only for voice, it could also be used for video, okay? Typically it runs with UDP. And we have another thing with it, which is called a SIP, Session Initiation Protocol, which is there to manage the sessions, okay? It's a signaling protocol that goes very often with RTP, and also in our case, ED137. Okay. Here you can see, yes, well, we mentioned already we have UDP. It can transport anything, but in our case, we will be on audio, and it could be PCM or it can be encoded audio. It is timestamped, so we need synchronization, which is good. And you can also have what we call forward error correction, which means, yes, you can, if you lose information, you can reconstruct it because you send additional correction information. Okay, you can see there is in the RTP protocol. This is the standard header that you can see here. You can see there is one file with one X here. This is a flag. This is an extension flag that you can use, and this extension flag is used for ED137. You will see this in another slide. Okay. Sorry, not the right one. And yes, here we are on ED137, which means, yes, we're really on a specific standard, okay, that initially has been developed for air traffic management, okay, in the control centers. If there was an Austrian company, one of the leaders for the control centers, which is Frequentis, they push this a lot. We work also with them. So it's, yes, it comes from air traffic, and then it started to get used a lot in maritime also. So when we were one of the first to use it, this is, yeah, it has some advantages because if you use this protocol and you can have interoperability, easier interoperability between the suppliers. For example, I give an example. We can use our system, our transceivers, receivers, and transmitters with a Frequentis system because we are ED137B. It's a little bit of integration because we are still in the world of of IP. Okay, it's not just like a physical, but it's way easier than having a proprietary protocol where you would need specific gateways and things like this. So we can have an easier integration. Okay. Also, the advantage is, yes, because obviously there are many possibilities to do the audio encoding. And yes, we agreed, this is once for all, is agreed that we have the G711 audio encoding, which is an audio encoding, not very difficult one, it's an easy one, and also very well adapted for voice communication. Yes. So how does ED137? What are some specific things? So we use SIP. I will have another slide on the SIP between this. Okay. So as very often in an RTP, but we have some more things that we need for the communication system. So we would have the PTT for transmitter that we transmit. Okay. Then the information on the squelch for the receivers. Okay. If there's no audio, we will not communicate. Okay, but we have something which is not really with the SIP protocol initially. It is we have a keep alive function, and you can see this in the picture below. All the violet packets here. These are the packets that you would send just to keep the session open, to keep it alive, and then you have the green ones. These are the RTP packets with voice packets. So if you are really communicating on voice, so we keep the session open. That's the goal of this. Sorry, thank you. Then we have yes. Where do we use this? For GMDSS, we use this all audio. As soon as you have audio, in our system, we will use ED137. Yes, it's really adapted to audio. Okay. And you can see here, this is the modified header we have for ED137. Okay, so we had the RTP general header before. This is the specific one. So you can see that the X here is set to 1. This means we have an extension flag. And then on the extension, what is the header extension? You can see here the type is 67 hexadecimal. It means we are in ED137. Okay, and you can see, yes, the other information goes then with it. Let's see here. Sorry. I mentioned already that in the standard we also have defined the audio encoding. So the audio encoding, we are in the world of PCM, okay, which is which is basically you will sample the audio. So we have a sample frequency. In this case, it is 8 kilohertz, okay, and you will take the audio on each one and yes, and as you can see here in the sinus, okay. So once we sample the audio, there are, how to say it, you could just sample it like this and send it like this, but there are ways to optimize the audio information that you get more, because you can see here in the sinus curve, for example, you know, sometimes you have fast changing values and sometimes lower changing values on the top. So there are mechanisms we call quantization that you can use to optimize this. In the case of G711, there are two. We have one mainly used in the United States and Japan, and the other one most in Europe and Asia. Each has its advantages, disadvantages. Well, it doesn't really matter on the complete system. And yes, we are in, just for information, we're in mono. This is really about optimizing voice communication and not about having a fantastic audio quality as we could have this in broadcast, okay? Yes, so it brings us to, if you calculate the bit rate, if you have 8 kilohertz and 8 bit, we always have something like 64 kilobit per audio communication, okay? Yes, this is a general slide about SIP, okay? So the SIP protocol, yes, as mentioned before, this is about managing the session, okay? So it's a session initiation protocol. It's just, we use it here, but it's not only used here. We have this in most of the IP telephone systems, mobile phone over LTE. So it's very commonly used, okay, and a lot with RTP. It is a peer-to-peer protocol, which includes some elements of HTTP and SMP. So it describes the future audio session, okay. And for doing this, we use what we call the session description protocol. They are carried as a payload in the SIP messages. We show you another slide with the Wireshark. Then you can see this. It's independent of the transport layer. You can use TCP or UDP. We have it here. You see here that no further exchange when RTP stream has started. This is not exactly true for the case in AD137. We will have, you know, this keep alive feature that keeps it open. Okay. So yes, you can see on the right side, it's mainly about, yes, you're asking and then you get an acknowledgement and then you say bye bye and so on. Here we have a protocol. This we wanted to show you. This is a Wireshark capture. And because we have good tools, if you have IP networks, we have now good tools to analyze them. And this is a Wireshark from a SIP from ED137B, Marc?
Yes.
What is it?
Yes. In fact, what is very practical with IP generally and with the standard protocols is that we have tools that may display all details of the protocols. So we can see if there is a failure, for example, on the network, we can have a proof of what is happening. And so in Wireshark tool, we have first a part of where we can see general information with IP source and destination information, and a small protocol analysis. So you see someone, the source is sending to the destination the request to invite. So this is SIP protocol. And we have response of trying an OK from the SIP server. Here, this is the transceiver. And if we come yes, deeper in the details, we see in the invite request also the audio console, for example, that we will show just after, is sending what is expecting as audio formats. So it's expecting to have audio and using this RTP port, for example. So it says, okay, now I will send you this audio on this RTP port. And I'm expecting you also send me your audio, if you are a receiver, to the same port. So this is a detail of what is needed between the communication between the audio console and the transceiver. And in the last part of the Wireshark tool, you have if you really need to, you can analyze bit per bit the exact protocol which is exchanged between both equipments.
Yes. So we mentioned already one of the advantages of IP networks is that you can, yes, you can have remote maintenance. This is a typical thing that we would use, if you face a problem in your system, one of the first things in general we ask then is you take a Wireshark capture, and then with this we can replay this here. And yes, and check if it's our equipment or if it's in the network and so on. So we can, with this, you really can do many things remotely, and also we solved already many problems with this. Okay. Yeah. Okay. So there we are through all the standards that are used in our IP standards that are used in our system. So then I will show you step by step how it's implemented here. So in this slide, you can see, well, the main parts of the equipment. So in the center is the GMDSS server. So you have understood already we are on a client server software structure. You can see on the left side, these are the consoles. So we have an audio console. And in the audio console, we would have then the encoders, the G711 encoders that we have mentioned. Okay. Then we have DSC Navtex console, and we also have an audio player, small audio player that can allow you to play content that has, that communication that have been made before. We have here on the right side, so we have the main equipment that you would need for a GMDSS system. So we have a VHF transceiver, MFHF transmitter, MFHF receiver, and what we say here, the Navtex. In this case, is the Navtex modulator. Okay, it can also be demodulator. Just for your information, you can see we have SNMP and NTP on the server. Yes, this is, and also not only on the server, we have also SNMP on all our equipment. We don't talk about SNMP here. It's also IP, but this is really just for the monitoring. Okay. Another thing you see already on this slide is you have the G711 encoders also in the equipment on the right side. Okay. So this means we encode and decode directly in our equipment. Okay. The idea is to create an XML file in the equipment, in the transceiver or transmitter or receiver directly, that then can be exchanged over IP. Okay. Another thing, yes. Then let's do this step by step. So let's do, what do we do with HTTP? So HTTP, you can see these are all the things we do with HTTP is, yes. The first thing is HTTP is obviously used as for the web interface. So for DSC and for Navtex, there's no audio communication. So we just need a web interface to connect to the server, and you can use then exactly the interfaces on the server for your DSC and the Navtex messages. Okay. It's also used for configuration. This is, if you see above, the audio console. The audio console will make a request for the configuration from the server, and it's used for control and monitoring. In this case, I know it's not very well. You can see it's bidirectionality. It means, okay, so you have to arrow with two-headed arrow. Okay, arrow. Sorry. So you can have, yes. So the server will request, to get, for example, the monitoring information, and the VHF equipment will ask for the configuration. Okay. The next one. Yes. What do we do if we add FTP? Well, FTP, in this case, you would use FTP. Then typically, we mentioned this already, for exchanging the XML files, for DSC and for Navtex. Okay. So you can see in the case, if you have a transceiver, it goes in both sense. Okay, you can send and transmit. And if you have a transmitter, you will push the XML files to the transmitter. If you have a receiver, you will pull it from the receiver. Okay. What else we have? And then if we go with ED137B, you will add then all the audio communication. Okay, so what you see here is all the equipment that we use for audio. So the Navtex is not concerned. But yes, VHF, MFHF, we can use for audio. So we have here we have ED137B. It's not just for the equipment. You can see. So how does it work? You will have the console on the left side, the audio console that will do the communication with the equipment. Okay, but the audio console is also linked to the GMDSS server. Okay, and the GMDSS server, for example, it is then used to record the audio files, all the communication that you can have. We have a feature, it's an option, but largely used option, where you can, yes, do the audio archiving. And this would be done in the GMDSS server. And for this, you would also use, to get the information, you would also use the SIP protocol, the ED137 SIP protocol. And yes, you would save then the audio in form of WAV files. And there's another thing you can see here below. If you go to the public network, okay, public telephone network, you also use a SIP protocol, a special standardized SIP protocol for public networks. Okay, and then the last one. These are just to tell you, okay, for the NAV text for time being, we still use on this one 2 proprietary protocols. Probably will be in the future, very soon future, we'll have it as the same. But just to say, okay, it depends on the architecture, so we can add protocols if necessary. It's a flexible architecture. And then I think we can start for the demonstration for the next part. Just before I will explain you what's the demo about. Okay, so here we have, you can see this is the basic equipment we have. We have more than that, but this is just the basic equipment that you see. So the one photo. So we have a VHF transceiver. This is exactly what you saw before. We have the NAV text and the MFHF receiver. Okay, we have the MFHF transmitter. These all come from Kenta. Okay, this is equipment from Kenta. It's, as I told you, it's IP RF gateways, if you want. So yeah, so we have conceived it like this. Then we have also Nautel equipment here. This would be the NAVTEX transmitter. The NAVTEX transmitter would come from Nautel. Okay, and yes, we have an interface with the Nautel. We would use our modulator then, and the transmitter from Nautel. You can see, yes, in the red circle, this is the GMDSS server. So this is what we will show you in the demo is mostly the GMDSS server. Okay. Yeah, this is just a slide here. You have the complete solution. This is just more to say, okay, we will not do all this. Don't worry. It's just, here we have, all what's possible. Yeah. So you can see we have on the left side, we have a complete VHF station, typically with 4. We can have as many as you want. Yeah, typically with 4 transceivers. You have the typical receiver. If you want to have it as IMO recommends, you would have 6 receivers on the MFHF frequencies at the same time. Okay, we can have redundant systems on the MFHF transmitter. We have a 1 kilowatt MFHF transmitter with a switching matrix and ATU if you want. For the NAVTEX, we can use the Nautel part, and NAVDAT. We also have NAVDAT ready equipment from Nautel, which is based on their NX series. Okay, and we can also have third-party equipment. It can be transceiving or transmitting or receiving. For this, we would use then our IP gateways. Yeah, so it's lots of things are possible. We will not show you all this. But in the lower side, you can see our software, our control center software. You see the consoles. Okay. You see the consoles here, voice over IP consoles, the DSC consoles here, the NAVTEX console. We have the archiver function, okay? The server here, which is the center of the system, and the server can be redundant. You can see all this. So this is just to give you an overview, total overview. And on the next slide, you will see what we really have prepared. So we have installed here in RAN, on a server and on a PC, on Marc's PC. This is why we are both here. We have installed an audio console and a server, okay, complete server that will handle two live VHF transceivers, okay, with 2 different models. We will have an MF transmitter, MFHF receiver, which we will group. But I'm just explaining this right away. We will put these together typically in the software. It's not the hardware separated, but on the software side, we will use this as a transceiver group. We'll see this in the next demonstration, okay? And then we also have some transceivers, but these ones are not transceivers; they are simulators, okay? We have simulators and also a NAVTEX modulator simulator. Why? Because yes, this is good to know. Because for testing, you don't have all the equipment always available. So we have simulators that we would use to do this, and yes, and this can also be used for training systems and things like this. So then we switch over to the demonstration. Okay.
Maybe up.
Yeah.
So yes, here we accessed directly to the GMDSS server web interface. So in a usual web browser like Microsoft Edge or Google Chrome, we can just enter and access the GMDSS server using its known IP address in the URL bar. And then our server can be accessed using user profiles. So we have different logins and passwords, which gives access to different parts of the GMDSS server features. So I will log in. You see on the top of the web interface, there is now many icons, which is different feature of the GMDSS server. There is a lot because we can manage all equipments. So we will define this in the architecture. We can manage the monitoring. So this is a two GMDSS server management and network supervision tool. We can manage all the users' rights, which can be connected to the GMDSS server. And then we have audio specific tools, DSC specific tools, and even more NAVTech specific tools. What I will show you first is to be connected to what we just see with many IP protocol, is how to quickly how to configure each transceiver in the GMDSS server. GMDSS server has all the transceiver information, all IP addresses, and all protocols which will be used by the audio console, by the DSC console to communicate with equipment. So here I just went to specific transceiver configuration. Here we have a specific transceiver IP address definition. And then, of course, you define the type of equipment you are communicating to, because there is always specific stuff to know if this is a VHF equipment or MFHF, if it has the TX transmitting feature only, or with RX feature, for example. And then under each transceiver, you can define each protocol we just saw. So for the transceiver control, we will communicate with the transceiver using HTTP clients, so HTTP protocol. For the audio and push-to-talk feature, we will use ED137 SIP protocols using, of course, same IP address and specific ports. For GSC, because this transceiver is able to do either audio or GSC modes, for GSC, as we see, it's FTP protocol which is used, and we will push some files for transmission in a specific folder, which the transceiver is waiting for files in that folder to transmit. Or for reception, this is also FTP protocol, still the same IP address, of course, but with the folder is not exactly the same. This means the transceiver, each time it receives some DSC message, will prepare an XML file inside that folder, and the GMDSS server will get these files by polling and will display on the GSC console. So what we want to see you just there is that we define a transceiver with each protocol, and some transceiver, like Hermann just explained to you, are groups which are composed by TX and by RX. This is made to simplify the operator management, so it can receive and transmit messages communicating to one virtual equipment, which in fact is two separated hardwares. Maybe you want to tell us something else?
No, okay. I think this is okay. I think for the just that you understand the general architecture. So the architecture, basically, this is always, you have this in all our equipment, by the way. We'll show you on another one. It's always about defining the input and the outputs of the system. This is the main. And this is the tool. This is exactly where you would, in the architecture, here you will define then all the IP address of all what we have shown just. Okay, because these are inputs and outputs from the server point of view. These are inputs and outputs. Okay.
Perfect. So then we will show you how the audio console, our software dedicated to make audio communications, how the audio console is getting this information from the GMDSS server to be configured, and then the audio console can be used, of course, to make audio communications with transceivers. So we have here, we have placed on the console, the operator has login with a specific login, and we see we have some phone lines, some transceiver 1, some transceiver 2, and some other transceivers with some status. This one has a small problem, so there is something to be known about this. So there is a red light. You can click on it and have details of any problems, if any. And now we will use this one to establish an audio communication. So between the audio console operator to a real boat, for example, on the VHF channel 16, which is a distress channel. So, for example, we have a microphone with a push to talk button on the operator console. And if I press the push to talk button, I can make a communication and to transmit. So you see there is a red transmitting information. So I am sending audio to the boats currently. And in the opposite side, I have a boat transceiver on my hand. Yes, I don't know if you can show it here. It's on the boat. Normally, it's on the main board of the boat, and he receives the audio and can also transmit the audio. And you see when I am the boat now, and the operator is seeing the audio coming, and the equipment is being green on the console. And if I release the button, the equipment is still green for some few seconds, so the operator can clearly identify which equipment has just called for distress. So we can now, okay, I know this is this one. I can click on it and can answer to the appropriate transmitter to the distress message, for example.
Yes.
You want to see something else? Maybe?
Yeah, you can. This is, this is. You saw this on the GMDSS server. This is of course this was about configuring. This is more about for the operator how to use. And this is this is why we have this interface to you see the elements, the graphical elements, and yes, we have the basic functions to make the life as easy as possible for the operator. For example, you can use for the receiver. You can use the squelch information if I'm correct. Can you? Oh, we need to. Yes, we have the squelch information. And we have also, if you transmit, you can also have the power that you use at the same time. Okay. You can click on anything else we can show. I think this is for the audio. So you can see it's a very convenient audio console, and I think they also drag and drop features to get equipment to the screen, and you can also take off. So yes, this is how to say, this is to make a convenient user interface. Okay, and then
so back to the server, we have also the same kind of console for DSC messages, which is more textual format. Maybe yes. Hermann, I will let you present because I will use a boat receiver.
Okay, yeah. So here, this is the console. If you look at the console, so we have on the left side, we have, yes, all the messages that would appear. And on the right side, you can see the equipment that you could use for DSC. So you can see here we have we have configured here 3. Okay. So we will send one. What we'll do now, we will send one DSC message. This is a distress. Marc is just pressing now the button for the distress. You can hear it's transmitting. And then you can hear, you can see, okay, it will appear. Yes, there will be a noise, just to an alert that the operator says, oh, something is going on. So here we see, yes, we have a distress alert on the, how to say it, from a boat. You can click on it if you want to have more information on the distress alert, okay? And then I think, Marc, you can press on the cancel button. Yeah. Okay, we'll wait a little bit. Okay, same thing. Distress. So you can see, take off the noise, and then yes, this is the message then from the transceiver to say, okay, I'm not anymore in distress, and this closes then the topic for the operator. No? Anything else we should show on this? Ah, yes, maybe
sending part maybe.
Yeah.
Of course, the operator on specific message is able to reply the distress alert with no specific DSC standard kind of message. For example, for if the port is has this signal some distress, the operator can say now we will communicate using VHF with appropriate channel. So this is the content of the DSC message. Also, we can the operator can select a new message, can send test message, which is a procedure in the DSC standard. We have to send test message every day to be sure that every transmission site is working properly and reception site is working properly. So they are used to send 50 individual call using VHF, and then they click on a new message, and they decide the details, in fact, of the DSC message.
Yes.
So this is the part of DSC standards, and it is very well known to the DSC operators.
Yes, most of you know this because this is it's standardized, and everything is standardized. You know which color and which sound and so on, that the operator knows that something is going on and so on. So all this is implemented here. Just to repeat this, okay, we can access to this. It's just with a web browser you can access to this to the server, and you can use the DSC feature without any additional equipment. Yes, there's one thing.
And then last but not least, we'll show you how now we saw the operator side. We can also have some administrators, some supervisor of the system, which want to know if every equipment we are managing is okay and healthy. So we have network supervision tool on the web interface of the web server, and as the same in architecture. But with non-settings now, we have only monitoring information. We can see that, for example, selected the transceiver, the HTTP link is working okay. The FTP link is connected, so it's okay. For audio is well connected, so it's okay. And we have additional monitoring information here that it can report to the server to know if everything is okay. As we just discussed, our equipments are also, the transceivers are also HTTP based for monitoring and control. So they have their own web interfaces also that can be accessed to set specific settings or to get more information on how it's going on. So for example, if I click on the access button here, this is the web interface of currently one of our transceiver, which looks exactly the same as the GMDSS server. All our web interface are uniform. So they are same kind of appearance, same kind of settings tree and pages to make the settings.
Very good. Very good. Very good. Okay.
And then GMDSS server management, it's reporting its own health. Of course, all transceivers are maybe okay, but maybe GMDSS servers has something to say. So GMDSS server can report some alarms, either instantaneous display with now we see we have some transceiver problem. We can see details about the problem. So it says there is a major alarm currently on some of the transceiver. We saw this previously in the audio console. If you remember well, there is a red light. This is how it is reported in GMDSS server.
Yeah.
And if you want to see a log file of what all happens in the time fashion, you can access the event log file, which will say the problem appeared at this time and disappeared eventually at this time.
Yes. So
I think that's it.
I think, yes, we have done our, we want to keep a little bit of time for questions. Then we can go back to the, we have one last slide on the summary. We can come to the summary and then you can ask your questions if you want. Okay, so to make it, to sum it up, IP networks are ideal for GMDSS systems. Okay, we have now with increased bandwidth, easy configuration and good analysis tools. This allows us to have a lot of yes, a very comfortable way of using it. We have now in our systems, in the IP-based systems, they are redundant. They can have redundancy, which makes them very reliable. They are scalable. You know, you can add equipment. They're flexible. If you have a new software version, you can just upgrade and things like this. Easy to maintain and supervise. You saw this with the demonstration we saw here. You have the different ways of supervising. You have with HTTP interface, with SNMP, and so on. Many possibilities. And then yes, with ED137. Yes, you have an open standard which is available for maritime communication that gives you interoperability. It is yes, which is already used by many of the main control center software suppliers as frequencies. And you get also, you know, the good things from the air traffic systems, which are at high levels on security, which then also can be, you know, leveraged here for the maritime communication. And yes, and we think, yes, this is also future-proof because most of the future equipment will be on this standard. And this is for our part. So I switch back to John.
No.
Thank you, Hermann and Marc. We're going to take some questions in a moment, and just a quick comment on next steps for anybody viewing. Certainly, you could reach out to Hermann and Marc for any specifics or questions you may have on your deployment. For asking questions, I'll just remind you that there is the question field. If you click on the orange bar to make sure that your control bar is fully exposed, you can enter in a question and send it through to us. I've got a couple of questions here. One is, what radios are we utilizing for VHF and DSCs? If you have a comment.
Yes, we are using our own. We have our own, as mentioned before. We do our, if it's for complete Kenta system, we always use the Kenta equipment. So for VHF, we have a KVHF 4013 model now, which is completely software-defined radio-based. And this can do DSC. For VHF, it can do DSC and voice, both. Okay, so it's our equipment. It's a 2 rack unit equipment that you can rack. Okay, and then we have, yes, we also have our own transmitter, which is a 29 rack unit, which is a bigger one, 1 kilowatt. And we have also receivers, MFHF receivers for, it's a 1 rack unit that you can rack in, and same thing, you can use both the transmitters and the receivers for MFHF for voice and for DSC. So it's our own equipment.
Great.
We're using.
Thank you.
But if ever somebody says, no, I want to have, or have equipment, I want to reuse it, it's a possibility to do. We have the IP gateways that we can manage also third-party equipment if necessary.
Okay, well, that kind of leads into the next question is, you know, if a coastal authority has an aging infrastructure, what are the implications for them updating? Would they be facing a wholesale forklift kind of upgrade, or do the standards approaches give a way to integrate more gracefully and take advantage of what they have? Do you have a comment?
Yeah, there are different scenarios. How to say? If they have, yeah, typically they would need to change the software. I think the software piece, the control center software, to be up to date. Okay, and then you can, for the equipment, we can do it step by step. We can use in the first stage our gateways, and then in the second stage replace the complete equipment. This is how it would work, typically.
Okay. Thank you. And maybe a last question from me, or there might be another one coming in here, but if one of the attendees wanted to understand their options for enhancing capability or upgrading, how can you help?
Options for enhancing the software?
What help can you provide through advice, or how would they get involved with you to try to sort out their choices?
Yes, yes. Obviously, you know, our software is not static. We are continuously working on it. Okay, and in general, our customers today they then have also a service level agreement with us, so we will continuously improve. And then yes, each how to say, typically we'll have a period of several months. If we have a new system, install a new system, we have a period of several months, and then there will be some forth and back with the customer to just that we have the system that he can use it as he wants. and then it depends a little bit, but sometimes we have to add new features to make it happen. But sometimes, yes, we just need to configure. It's enough to configure. But yes, typically we listen to the feedback of our customers, and this is how we have, over the years developed the complete system that we have shown.
Okay, I do have a few more questions here. Are your systems, can they be compatible with a TAIT radio?
TAIT, yes, we know them. Yes, this is possible. We have this, for example, in Croatia, where we use this type of radios. So it is, we can use this, but you would need to use then our IP gateways, okay? But with the IP gateways, they can interact with TAIT. We have done this already. It's possible.
Okay, and maybe this is a similar kind of a question. Could an authority utilize your radio equipment and interface it with a Frequentis system, as an example?
Yes, we can.
Okay.
We can. So just for the complete information, we have already how to say it, done this with our MFHF receivers. Okay, so it means we have already integrated part, but if typically it takes, let's say 2 to 3 weeks to integrate. It's not big work, but you have to count a little bit of time to get it completely running if you have new equipment. But yes, we very easy to do because we have already ED137B, the same Frequentis.
And there's a question: can we get a recording of the webinar? I'll answer that one. We're just about to launch a new website, so the recording will be posted there. But if you can bear with us for about another 2 weeks, we'll be able to find it. You'll be able to find it there. A couple of more questions here. Let me see. Is there a solution to reduce echoes generated by the reception on 2 adjacent VHF coast stations?
Oh, this one. We have echo cancellation, but Marc knows this better than myself.
Yes, we have echo cancellation in audio console. So we need to define adjacent region, geographical adjacent regions in GMDSS server. So the audio console knows both or third transceiver are next to, and there is echo cancelling in audio console. Yes.
Thanks, Marc.
This is a hot topic. This is a good question because yes, it took us a good several months to have this feature implemented, but we have.
We're coming up to the top of the hour, so I'm just going to take one more question, and we may be able to get back to some of these questions directly through email. But apart from the radios, do you provide design and advice on the antenna arm?
Yeah. We do. We have the expertise in house. Okay, so we can do site surveys. We can do we also can do things already remotely. We can give typically, even if during the offer we give a first advice to say, okay, this is how we would do it, and then yes. So this is one of our strong points that I mentioned in the very early slides. So it's not just about software. We also have the guys in the field that know how to manage, especially for the lower frequencies.
Okay. Thank you, Hermann, and thank you to all that have attended today. We're going to close out the webinar now, but I ask you, this is all about education and making sure that if we do more of these webinars, that we're giving you the information that helps you. You're going to find as you exit the webinar an exit survey, and we ask you to use that to give us ideas on topics and let us know if this was useful for you today. But from Marc, Hermann, myself, John White, thank you very much from Nautel and Kenta. I hope you have a great rest of your day. Thank you.
Thank you.
Thank you.